Hello students, so in my last lecture I started the topic photovoltaic cell, and that is a type of photoelectric transducer, or you can say that is a type of optical detector. So in the photovoltaic cell part, before discussing the working principle or the working of photovoltaic cell, I was discussing few terms that you need to know for the better understanding of this photovoltaic cell. So there I discussed about the p-type and n-type semiconductors, and next that I'm going to discuss here is what will happen if p-type and n-type semiconductors they are put together. So as I've told you, this n-type semiconductor is having excess of free electrons and p-type semiconductor is having excess of holes. So when p-type and n-type semiconductor they are put together, what will happen? The electrons, this is p and this is n, the electrons from n side will go to the p side to fill the hole in the p side, that is electron hole recombination will take place. Whereas this hole filling happens in a small stripe where the p and n type semiconductors will touch. What I'm trying to say is that what will happen, since n type is having excess of free electrons and p type is having holes, so the interface, near to the interface, the electrons which are there, they will cross the interface and they will come in contact with the atoms in the p side and they will fill the holes there. Now since this atoms initially in the p side they were electrically neutral, but after gaining this electron, because of this electron hole recombination, after gaining this electron, these atoms will be negatively charged because now they are having excess of electrons. Whereas atoms in the n side, which is near to the interface from where the electrons, from where the free electrons has gone, has crossed the interface and gone to the p side, those atoms will be depleted of the electrons and they will acquire the positive charge. So this is what we call depletion region. So depletion region occurs near to the interface, and in the depletion region, in the p side, the depletion region is having negative charge, whereas the n side is having the positive charge. Now this process will keep on going, means the electrons from the n side will keep on moving towards the p side. So will keep on moving towards the p side until and unless what will happen, the electrons from n side will keep on moving towards the p side and will make the atoms near the interface to be negative. So this process will keep on will keep on continuing until the negative charge in the p side of the depletion region is strong enough to repel the electrons, or to repel the electrons from further crossing this interface. So once this negative charge on the p side is strong enough, no more electron from the n side will be able to cross the interface and go to the p side and form the electron hole recombination, because this negative charge is repelling the electrons, because we know like charges repel each other. So this is how depletion region works. Normally what will happen, we have p-n junction, we have negative charge on the depletion region and positive charge on the depletion region, and electrons will keep on moving from n side to p side to form electron hole recombination until and unless the negative charge on the p side of the depletion region, that is atoms that have gained this negative charge, are more in number, that they do not allow electrons from n side to cross the interface and go to the p side for electron hole recombination. So this is how p-n junction works. So this is what the electric field barrier of this depletion region. Here this is the depletion region, this small stripe is the depletion region. On the p side we have negative charge, or on the n side we have positive charge. So this is the electric field barrier of the depletion region, and at this point electrons are pushed away from the depletion region by the electric field, and no more holes are filled in the p side. Now what is the role of sunlight? Where does sunlight come into play in this process, in this p-n junction process? So as I have told you that the depletion region, again one more thing that I would like to conclude is here that in the depletion region, this is the P side, this is the N side, and this is the interface, this is the depletion region. So towards the N side we will have negative charge because atom is having excess of electrons, and towards the N side we have positive charge, that is atom that are depleted of the electrons. Now what will happen, as we know light carries energy. How sunlight is coming into play in this whole process? We know light carries energy, and when light hits the depletion region, when light is going to hit the depletion region, it can cause electrons to leave the holes they filled. I've told you that electrons from N side, this is N side, this is P side. I've told you that electrons from N side were crossing the interface and filling the holes in the P side to form electron or hole recombination process. And that's why we were having here the negative of atoms, because these atoms were having extra electrons after the electron hole recombination. So when light will hit the depletion region, this electrons, it can cause the electrons to leave the holes they filled. We will have free electrons now. So what I'm trying to say is that this is the whole PN junction with the depletion region. This is the negative atoms in the P side of the depletion region. These are the positive atoms in the the positive atoms in the N side of the depletion region. So what I was trying to tell you that initially what is happening, electron from N side is filling the hole in the P side. So here the electron hole recombination has taken place. Now once the photons will strike the electrons that has filled the hole in the P side of the depletion region, once the photon strikes this type of electrons, so after gaining the electrons, electron will leave the hole they have once filled. Now since this is the depletion region, now since the P side of the depletion region they are negative, and when sunlight will fall on the depletion region and it will hit the depletion region and it can cause the electron to leave the holes they fill. These electrons after getting free in the depletion region, they will be repelled by this negative charge in the depletion region towards the N side. Now as an outcome, what is happening, we have electrons here and we have a hole in the P side. So there is a hole in the P side. The negative ions around the ejected electron, the negative ions, these negative ions around the ejected electron repel it back into the N-type material. Now with one less electron filling a hole, there is a room for a new one. But how can the electron get past this electric field barrier made up of all negative ions? What I am trying to say is that initially this depletion region has been formed. There is negative charge in the P side of the depletion region and positive charge in the N side of the depletion region, which is not allowing further electrons to move from N side to P side and fill further holes in the P side. This is not allowing. The electric field barrier of the depletion region is not allowing. But what is happening, when the light will fall on the depletion region, it will the photons will give its energy to the electrons, and electron will leave the hole that they have initially filled, and because of the negative charge in the P side of the depletion region, this electron will get repelled and they will move back to the N side. Now there is a new room for the electron to be filled, because there is a hole here in the P side of the depletion region. There is a hole which needs to be filled. But how can the electron from the N side be able to fill that space again? Because there is a potential barrier of the depletion region. So what can we do? Now connecting the P side and the N-type side with an external wire or circuit which acts as a backdoor for electrons. So the electrons that left the P side and came back to the N side, making a vacancy for the electron here. This vacancy can be filled from the back door, because electrons cannot directly fill after crossing the interface, because the potential barrier of the depletion region won't allow that to occur. That's why if we connect a p-type and n-type material through a wire through this back door, what will happen? The electrons will go back door and fill that vacancy, and this is resulting in the electric current flow. So when the electron is back at the p-type side, the solar cell goes back to its original state, and the process can repeat for as long as the sun shines. In summary, concluding that how the whole cycle is happening over and over again, how the whole cycle is happening. The electron inside a hole is hit by the light in the depletion region. The electron which is inside the hole, that is in the p side of the depletion region, in the p side of the depletion region, the electron inside a hole is hit by a light. It is hit by a light, and the light's energy causes the electrons to be ejected. So here in the depletion region, an electron has been ejected. The electric field created by the ions, this negative electric field created by the ions in the depletion region, pushes the electron towards the n-type side. Now there is an additional hole in the p-type p-side region, and this hole wants to be filled. So an electron takes the back door through the wire or circuit to fill that space. So this is how photovoltaic cell works. So I'm ending this class here. We'll discuss more about the photovoltaic cell in my next lecture. Thank you.